Graphing exponential functions. The graph of an exponential function is called an exponential curve. In this example, create a table of solutions and graph. f of x equals 2 to the x power. So with our table, x and f of x, let's let x be our numbers between 3 and -3. And we want to start by substituting the -3. f of -3 equals 2 to the -3rd power. This becomes 1 over 2 to the 3rd, which is 1/8. Substituting in for -2, we have f of -2 equals 2 to the -2 power, which is 1 over 2 squared, which is 1/4. f of -1 equals 2 to the -1 power, which is 1 over 2. f to the 0 power is equal to 2 to the 0 power. Anything to the 0 power is 1. f of 1 equals 2 to the 1st power, which is just 2. f of 2 equals 2 to the 2nd power, which is 4. f of 3 is 2 to the 3rd power, which is 8. With our graph, we have -3, 1/8, -2, 1/4, -1, 1/2, 0, 1, 1, 2, 2, 4, and 3, 8. Our line will come close to, but never cross, the x-axis. One of the common features of an exponential graph is that it starts off slow, then it starts increasing rapidly. So when our x was negative, our dots were fairly close together. Then for 1, 2, and 3, the dots become further apart. In this example, create a table of solutions and graph. f of x equals 6 parentheses 1/2 to the x power. So using our f of x table, this time we're going to use the numbers 0, 1, 2, 3, and 4 for x. Starting with 0, I have f of 0 equals 6 times 1/2 to the 0 power. That gives us 6 times 1, which is 6. For f of 1, that equals 6 times 1/2 to the 1st power. 6 times 1/2 is 3. For f of 2, 6 times 1/2 squared equals 6 times 1/4, which is 3 over 2. f of 3 equals 6 times 1/2 to the 3rd power, which equals 6 times 1/8, which gives us 3/4. f of 4 equals 6 times 1/2 to the 4th power, which equals 6 times 1 over 16, which reduces to 3 over 8. Now we're ready for the graph. So we have 0, 6, 1, 3, 2, 3 over 2, 3, 3/4, and 4, 3/8. It comes right up next to, but does not cross, the x-axis, which makes your x-axis a horizontal asymptote. An asymptote is a line that your graph just will not cross. Base multiplier property. For an exponential function of the form y equals ab to the x power, if the value of the independent variable increases by 1, the value of the dependent variable is multiplied by b. Increasing or decreasing property. Let f of x equal a b to the x power where a is greater than 0. Then if b is greater than 1, then the function f is increasing. We say the function grows exponentially. When b is greater than 1, it increases exponentially. If 0 is less than b is less than 1, then the function f is decreasing. We say the function decays exponentially. So it goes down from left to right when your b is a fraction. Example, graph the function f of x equals 8 times 1/2 to the x power. For this example, we want to use our graphing calculator. To graph our equation, we need to go to y equals. So we want to type in our equation, 8 parentheses 1 divided by 2 parentheses to the x power. Also, on the same graph, let's graph 1/2 to the x power. That way we can get a better idea about the base multiplier property. From here, let's click on Zoom, choose 6, which is Z standard. Now we have our two graphs. Make it a little bigger here. For my graph of f of x equals 1/2 to the x power, it crosses the y-axis at 1. For the graph f of x equals 8 times 1/2 to the x power, it crosses the y-axis at 8 because 8 times 1 is 8. If we click on second and graph, we have a table of our two graphs. When x is 1, y2 is 1/2. 1/2 times 8 is 4. When x was 2, 1/4 for y2, 1/4 times 8, 2. Since a was 8, all the values for y2 were multiplied by 8 to get y1. If we push our up arrow, we can get a little more information. Here I've got -1 for x, 2 for y2. 2 times 8 gives me 16. -2 for x, 4 for y2, 32 for y1. Intercepts. Y-intercept of an exponential function. For an exponential function of the form y equals ab to the x power, the y-intercept is 0a. Horizontal asymptote. For exponential functions, your x-axis will be your horizontal asymptote. That is the line that your graph cannot cross. In this example, find the y-intercept of the graph. f of x equals 6 parentheses 1/3 to the x power. Using our exponential function y equals ab to the x power, whatever a is your y-intercept. For this function, a equals 6, so my y-intercept is 0, 6. In this example, find the x-intercept of the graph. F of x equals 6 parentheses 1/3 to the x power. Because this is an exponential graph, it is not going to cross the x-axis, so we don't have an x-intercept. In this example, graph the function f of x equals 6 parentheses 1/3 to the x power. Returning to our graphing calculator, go to y equals, clear out the existing equations, and now we are ready to type in our equation. Our equation is 6 parentheses 1/2, close parentheses, to the x power. Graph. And we have a graph of our equation. So it crosses the y-axis at 0, 6, and it comes right up to, but does not cross, our x-axis. I can go to second graph, which is our table, and I have -4, 96, -3, 48, and it continues to get smaller. We have our y-intercept, 0, 6. If we go down, we get decimals, and they get smaller and smaller as we go down. Now we're into scientific notation, but we're not seeing a 0, so we did not have an x-intercept. Reflection property. The graphs of f of x equals negative a b to the x and g of x equals a b to the x are reflections of each other across the x-axis. For all exponential functions, the x-axis is a horizontal asymptote. The red curves are the reflection. The blue graphs have a positive a, the red graphs have a negative a. In this example, graph the functions f of x equals 5 parentheses 3 to the x and g of x equals -5 parentheses 3 to the x power. Returning to our calculator, y equals, and let's start with 5 times 3 to the x power. Arrow down, -5 parentheses 3 close parentheses to the x power, and we're ready to graph. The green graph is a reflection of the blue graph. Having a negative value for a makes your graph go down from left to right. In this example, input-output pairs of 4 exponential functions are listed in the table. Complete the table. So what we want to do is figure out what to multiply or divide by to get from one point to the next point. For f of x, we have an input of 0 and an output of 6. When we have an input of 2, we have an output of 24. We know that 6 times 4 is 24. So to get from 6, I had to multiply. The square root of 4 is 2, so 6 times 2 is 12. So if we have an input of 1, we have an output of 12. For an input of 2, we have an output of 24. 12 times 2 is 24. Then 24 times 2 gives us 48. So for an input of 3, we have an output of 48. Then 48 times 2 gives us an output of 96. So an input of 4 gives us an output of 96. Now we want to look at g of x. For an input of 1, we have an output of 192. For an input of 3, we have an output of 12. 192 divided by 12 gives us 16. Since there's a spot open between the 192 and the 12, I take the square root of 16, which gives me 4. 192 divided by 4 equals 48. So for an input of 2, I have an output of 48. 48 divided by 4 gives us 12. 12 divided by 4 gives us 3. So an input of 4 gives us an output of 3. We still don't know what and output is for an x value of 0. I would have to have a number divided by 4 to get the 192. So 192 times 4 is 768. So an input of 0 gives us an output of 768. If I take 768 and divide it by 4, I get the 192. Divide that by 4, 48. Divide that by 4, get 12. Divide it by 4 again and get 3. For h of x, I have an input of 1 with an output of 54, an input of 4 with an output of 2. So I have 2 empty spots between the 54 and the 2. Since 54 is larger than 2, I'm going to divide. 54 divided by 2 equals 27. Since I have 2 spots between the 54 and the 2, I want the cube root of 27. The cube root of 27 is 3. So to get from an input of 1 to an input of 2, I will have to divide everything by 3. 54 divided by 3 equals 18. So for an input of 2, I have an output of 18. 18 divided by 3 is 6. An input of 3 gives an output of 6. And then just to verify, 6 divided by 3 is in fact 2. We still don't know the output for the input of 0. What number would I divide by 3 to get 54? So I can multiply to go backwards, and 3 times 54 is 162. So for an input of 0, I have an output of 162. I can check my work by dividing all the numbers by 3. 162 divided by 3 is 54. Divide that by 3, and I get 18. Divided by 3, I get 6. Divide that by 3, and I get 2. For k of x, I know that when I have an input of 3, I have an output of 1029. An input of 4, I get an output of 7203. So I need to figure out what I can multiply 1029 by to get 7203. And the number I need is 7. Since we're given the bottom two outputs, we're going to have to divide to go backwards. 1029 divided by 7 is 147. So for an input of 2, I have an output of 147. Divide 147 by 7, and I get 21. So for an input of 1, I have an output of 21. Divide that by 7, and I get 3. So an input of 0 gives an output of 3. Checking my work, 3 times 7 is 21. 21 times 7 is 147. 147 times 7 is 1029. 1029 times 7 is 7203. In this example, we want to find the following. We have a graph of function f, and we want to know f of -3. So find -3 on my x-axis. From there, I go up to my graph, then over to my y-axis, where I have 8. Part B, f of 0. So I find 0 on my x-axis. I go up to the line. I don't have to go left or right. My point is at 0, 1. F of 0 equals 1. We want to find x when f of x equals 4. First find 4 on the y-axis. Then we want to go over to the graph, down to the x-axis, which is -2. So when f of x is 4, x is equal to negative 2. Find x when f of x equals 2. Find 2 on our y-axis, go from there to my graph, then down to my x-axis, which is negative 1. For f of x equals 2, x equals negative 1. Graphing exponential functions. When graphing exponential functions, they never cross the x-axis. If they go up from left to right, they're increasing. If they go down from left to right, they're decreasing. Base multiplier property. For y equals a times b to the x, a is your base multiplier. If the graph is increasing, it goes up from left to right. Decreasing goes down from left to right. For an exponential function, a is the y-intercept. Because it's an exponential function, there is no x-intercept. It never crosses the x-axis. So that's your horizontal asymptote. The reflection property states if I have 5 times 2 to the x and negative 5 times 2 to the x, the negative in front of a flips the graph. So all the y values would be negative.